So thank you very much for the nice introduction, and I'm very delighted to be here and then being the guest of IBERTIC. And I already had some talks in different parts of Argentina and then in Uruguay. And I hope we will be able to develop something, and I will introduce some of the development of GeoGebra. So maybe before starting this, I would like to give a little bit more background of me. So I originally been a mathematician, and I was working on numerical analysis, and then I was assigned to a course to integrate technology into a university level course on differential equations. And this was the most horrible course I've been to. And I thought that it should be a better way to introduce technology in the classroom. So I changed my subject to mathematics education, and I went to the University of Michigan and started to work on integrating technology into university level mathematics. And then I went to Cambridge to look at how mathematicians use technology in different countries. I looked at 1,100 mathematicians in the US and in England and in Hungary to see that what they are doing and what are their perspectives about the importance of technology in mathematics. And before this talk, I had a very nice discussion about some of these philosophical issues, that how mathematics is changing because of the new technology. So we have a 19th century way to teach mathematics, but technology is becoming part of the everyday life. But despite the hopes in the 1980s and 90s, the integration of technology into education is very slow, and probably it will take several decades or many years to be able to introduce something which is meaningful and successful. And in this talk I will introduce GeoGebra as one of the tools that might be able to show our perspective of how to integrate technology into the classroom. Because I think many of the people already agrees that if it's part of life, then probably it will become the part of the education. But probably there is a delay in this work. So I will talk a little bit about GeoGebra, and also I will talk about what could be done and how we can go forward together. So first of all, I would like to ask you if anyone here who don't know GeoGebra in the room. So everyone knows GeoGebra. So maybe I give in that case a shorter time for introduction. But in that case, I will talk a little bit of the history of GeoGebra and the international community, and what are the development for the software and other activities. And at the end I would like to talk about research that what I see is the key for development. So the history of GeoGebra is now more than 10 years old. So the original software was designed by Marcus Hohenwater as his master's thesis. So what he found that there were many software which were using a dynamic environment with dynamic geometry, and there were some software with computer algebra, but there were no really connections between the two. So the idea was to connect the two environments. And if you know GeoGebra, then you know the idea that whatever we construct on the geometry window, then it appears in the algebra window, and then whatever we change here, then it changes in the algebra view, or if we change something here, then it changes in algebra. So in that case, if we create a triangle, what we talked with Andrea is then this is not one triangle, but all possible triangles which could be done, because it's a dynamic environment. Then we can have a representation, and that is a very deep mathematical idea, that how to construct a general idea of a triangle, which means all possible triangles. And then that is one of the strengths of one of these tools which could impact education, is then that we can introduce general ideas, and also we can introduce ideas for students to be mathematicians. So when I did my study, and I told it in the group before, is that mathematicians who use technology for teaching, they are saying that they are using technology because they feel that this is a way for students to be mathematicians. Because in the school level, most of the time there is a teaching process. Then the teacher stands out and tells that this is a theory, this is a proof, and then it looks like a finished process. But the mathematicians' work is very creative, and they are exploring, looking at different kind of ways, and technology allows them to give this kind of power of discovering mathematics and exploring mathematics from a different perspective. So, for example, I usually show these examples that if we construct the perpendicular bisector, if we construct the perpendicular bisector of the triangle, the students would discover the different kinds of triangles what we can do. So in that case, the intersection of the three perpendicular bisector is point D, and okay. So in that case, if the point is inside, then the triangle is one of the angles is less than 90 degrees, exactly 90 degrees if it's on the hypotenuse, and then that could give inspiration for the Pythagorean theorem and Thales theorem, and if it's outside, then it's greater. So then that is a kind of investigation, and then students can follow this kind of work, for example, doing the circle around the triangle, and then try to look at that, why it is true, how to prove it, and so on. And in the discussion before, we thought that technology is only one tool, and then if we introduce it into the classroom, then students have a capacity to reach for paper, reach for GeoGebra, reach for other tools, reach for some kind of shapes. So then this is not a magic bullet to introduce technology, but then that will enrich the resources, and then could change the dynamic in the classroom. So in that case, teaching could become more like a projection activity to a kind of a teacher is becoming a kind of conductor of the classroom, to allow students to work with different kind of problems. I show you another problem in which I usually show is that if we start from the algebra view, so we can plot a function x squared, and if we plot this function, then we can ask students to investigate different kind of function transformations. So if you ask the students to do some kind of addition, multiplication, or something, then we can see that it's changing. And then when they get the general idea, then we can introduce constants which is very easy with sliders. And if we introduce these sliders, then we could generalize the functional transformation. Is it okay? So in that case, if it works for A, it would give the slope, the horizontal, and the vertical. And if it works for one function, the students can look at whether it's true for other function. So we can easily change the function for example, the sine, and in that case, it still gives the slope, the horizontal, and the vertical transposition. And because it's a periodic function, then we can change the period. So in this way, students can discover, but also GeoGebra is a good tool for teachers because it's very easy to construct their own examples, or they can use other examples from other teachers in different countries. So GeoGebra just got lots of awards, but what is important is that how to use technology in the classroom. So then this could be one part of the classroom activities. So many teachers use it for visualizing, connecting different fields of mathematics or experimenting. But what is important is that there is no one way to teach with technology. There is a range of ways to use technology, and what we need to do is that making teachers and students comfortable with using the technology, even if it's in a very small part, maybe in one lesson in a year, then they might be comfortable for later. So we discussed it before that just making teachers and students happy could really do the change on the introduction. So before I forget it, so if you would like to have this presentation, then and the files that I will show, there is a list then that you can send, write your emails, and I can send this presentation to you. So where GeoGebra is used. So originally we thought that it can be used for mostly secondary schools, but as many people started to use it, then is ideas from primary to university level. So I would like to show some of the examples and then that I found on the web. Probably you know GeoGebra Tube, which is a similar environment as YouTube. So then there are more than 43,000 examples already on GeoGebra Tube. So teachers can upload files, students can upload files, they can work with these examples, and then they can use other people's materials. So I will give some examples on what I found on GeoGebra Tube for different levels of education. I don't know if you know this example, that you have this bunny, and what we can do is that giving some kind of stimulation to understand the direction and the addition of negative numbers. So in that case, if we move the bunny, then it turns back and go to negative 4, and because then there is a negative number. And also students can play with this, that there is a 6 plus 7, whether the bunny will turn, probably not. So in that case. So this is a kind of visual representation of negative numbers. Of course, this is not the only one, but this might help students better understand the teacher, to better explain. And of course, then this could stimulate other activities. Another concept is the multiplication of fractions that I usually show. That is a quite difficult concept sometimes to introduce. So we can have the fractions here, and if we want to multiply the two fractions, what is the visual representation is then that you have 6 out of 48, and how the rule is changing is that if you start to change the denominator, then the denominator will change, and then get some ideas that how then the multiplication works and why, and then the numerator changes here. Okay. And some more examples. For primary school, I like this example is the Kaleidoscope. So in that case, what you can do is looking at symmetry, and then here you can change that how many symmetries you want to introduce, and then just play with this, doing this kind of symmetries, and then work on how and in these symmetries would work, or even you can have different kind of colors, and then it just makes it nice, and then it could stimulate some understanding of mathematics. Or another symmetry activity is with vectors. So you can have some pictures, and then you have two vectors, 1, 0, and 0, 1. And then how these vectors work with the translations. So if you change one of these vectors to -1 and 0, then you can also introduce the symmetry, and in that case you get a symmetry to the y-axis, and then with the determinant as well. And if you change it to -1, then you get a central symmetry, and of course you can investigate some special cases and so on. Okay, so these are some stimulating activities for students with visualization. So maybe some more. I don't want to show too many, but this is for parabolas, and probably you know this kind of game on on the tablet. So what we can do is that just having the speed and some things, and then we can look at whether we can reach this guy, or work with this. So these activities are quite easy to create, and also quite easy to find it on GeoGebra Tube. Okay, so or you can find for coordinate geometry then that you have a boat you need to find. So where is this boat? You have to go to 10, and then the boat is at 7. You have found the boat. So these are just little games which might simulate interest from students. So one more example for university level courses. So for example, calculating the integral, we want to find the upper sum and the lower sum, and then we are looking at the difference between the upper sum and the lower sum. And of course, calculating the area under the curve would need better partitioning, and then generate some ideas that how n goes to infinity, and then we can introduce the work on integration. Okay, so maybe I'll show you one more thing. Is GeoGebra is now used not only in mathematics but also in physics. So then this is a field of electricity. So if we put different particles, then we can stimulate that how it would work. So very simple, but it could generate some interest. So then this is some ways to use GeoGebra in the classroom. And from different teachers, I would like you to introduce some other things then that how GeoGebra is get used. Probably you know this Theo Janssen's beach beast. Probably some of you already seen it on.
Come with me, Wallace, to a windswept beach in Holland. Because this is home to an incredible creature that only needs a slight breeze to spring into life.
My name is Theo Janssen. We're here in Ypenburg in Holland, where I work every day. And here I try to make new forms of life, which keeps me busy 24 hours a day. And I want to put those out on the beaches where they can live in the future. And they don't have to eat because they get their energy from the wind.
Theo's been making his creatures for over 20 years, and he's evolving such clever designs that one day he hopes they'll be able to leave home and live permanently in the Dutch sand dunes.
So, I don't know if you know this kind of sculptures, but this is very interesting. And some students wanted to construct it by themselves, and they wanted to see that how it works. So they created this beast in GeoGebra, and then you can see that how it would work. But for constructing this, we need some kind of understanding that how this beast moves. So in that case, what we can do is that we can track the legs of the beast and see that one gives the stability for it to be able to move. So in that case, you can have the track of the legs. And then this is quite stable because then this is horizontal, and then there is a function describing it. But if you change some of the features, then you see that it could become faster, but maybe a little bit more unstable. Or if you change some other parts, then it might fall apart, or you can construct different things. But what is interesting that students seen it on YouTube, and then they started to create. And if you look at that how much energy they put into the construction, then how much mathematics they learned while constructing this beast, I think it's a very good way to introduce. They just get some interest and inspiration, and then they learn mathematics by themselves. And the student and the teacher's role is just to orchestrate, or maybe they are just doing it anyway. Another example for doing this kind of activity is that if you look at that how mathematical objects are represented in nature. So I think there is no sound for some reason. So then that is a video about geometry in nature, and then how the wings of a dragonfly is constructed. So you can see the pattern of the dragonfly, and then you can use GeoGebra to construct these patterns. And then, okay, so then that is quite easy to construct. So you take 2 points, and then you just color the difference between the two points, and then that will give you the basic pattern for the dragonfly. So if you take more than 2 points, then what you can do is that include it in the spreadsheet. So GeoGebra moved from geometry and algebra to a more general software with the introduction of spreadsheets and computer algebra. So in that case, you can still do this coloring, and because of this coloring, you get the patterns, which is the wings of the dragonfly, and it looks nice. So we introduced the software, but the creativity is coming from the community and coming from teachers and coming from students. I think then that is the power of working together and trying to work on education, and then see that how we can develop. So you see that the software can be used in a variety of ways, but is the basis of GeoGebra is the international community. So what we aim with GeoGebra is that we encourage people to develop their own ideas and share these ideas, and then we encourage collaboration. And then it works quite well. So GeoGebra become a very big project. Now we have more than 20 million students and teachers using GeoGebra in 85 countries. It's translated to 62 languages, and there are tens of thousands of GeoGebra materials on the web. There are more than 1 million visitors on the website. So it become a quite big project. So. And because it's based on collaboration, what we thought is that we should have an environment to share. So on GeoGebra Tube, probably many of you know, there are now more than 43,000 examples. So then this is a sharing environment. But to work with this community, we established the GeoGebra Institute Network, which is an informal organization, and that is powerful because people in their own country know much better the needs of the country, the requirement of the culture and the curriculum. So the aims of this GeoGebra Institute is to do some kind of teachers training and support, develop materials or the software, and do research, and then collaborate with each other, and then if it's possible to reach disadvantaged communities. So now there are 153 institutes in 85 countries. I think there are about 6 in Argentina. And what we try to do with this institute is that it's a group of people, and then try to encourage them to work within their country or across their countries. So what is very interesting, that where GeoGebra is growing fastest. So if we look at that, how GeoGebra is being used, then in the past years, definitely Asia, South America, and Africa is increased the number of institutes, and then there is the biggest movements are in these regions, especially here with the laptop projects here in Argentina and Uruguay and Costa Rica. And there are some other projects in different parts of the world. So the GeoGebra institutes are all different. What we would like to have them just do whatever they like to do, and then work in a collaborative way. So what we try to do with this collaboration is then that we should introduce some networks. So people are working in the same country, they should try to communicate with each other and try to collaborate. So we have an institute network in Spain or in the Nordic countries, and that would work really well to share activities and organize events. With the events, there are lots of events around GeoGebra. There are about 50 conferences this year, and then there are some bigger conferences like we had in Warsaw, and then we will have a conference in Budapest in January. But we had a conference last week in Uruguay and in many other places in the world. So to sum up with the community is what we are aiming for, that changing the kind of tradition from the 19th century way of teaching mathematics to 21st century. We don't really know what it is, but I think that is what we need to investigate. So one of the key for these things is accessibility. So accessibility of technology and resources. And the other thing then that might be changing the way of schooling and teaching is then the collaborative way. So rather than having the teacher telling the students what to do, and then the students collaborate, the teachers collaborate, and so on. And also being experimental, some interesting ideas happening. So there are some students in India, 10-year-old students, who become teachers, and they are training the teachers in the university because they are much more proficient in technology. So maybe the integration of technology is coming from the students. So maybe we don't really know that how it is happening, but I think we need to listen and being open-minded of what is the change. And this is true not only for mathematics but any other subject, and maybe the structure of the school could be different. So now I just give you a little bit overview of what is happening with the development. There are many more things, but just a little bit of overview. So GeoGebra has a developer team of 43 developers. Many of them are volunteers. So the development is done in Austria and in Hungary. And there are different versions of GeoGebra. So the most current version of GeoGebra is 4.2. So this is what you can download, but 4.4, which has many new features, can be already trialed. So one of the big step of GeoGebra was the introduction of spreadsheet and the statistical features. So in that case, it would cover fields of mathematics, in other fields of mathematics, and also it could be used for example, physics and other subjects to analyze data. And also, one of the features which many other software can do is implicit curves, which is a very nice feature. And then we are developing tools for interactive whiteboards, which in some countries is very important, like in England, that I just marked the thesis for students that more than 90% of the schools have interactive whiteboards. So maybe the laptops are a better idea, but I don't know. And also GeoGebra Tube. So there is lots of materials, and then we encourage people to share ideas, download ideas, modify it for their own needs, but share the new ideas with other people. Last year we introduced the computer algebra system part. So until then GeoGebra was more like a numeric calculator, but now it's a symbolic calculator as well. And we try to construct the computer algebra in a way that it should be accessible for younger students. So there are some software like Mathematica and Maple, which is developed from the research perspective. So then that were tools for mathematicians. But GeoGebra is developing from a different perspective. We need to have a software which is for teachers and for students. So it's coming from the pedagogical perspective. So the computer algebra view is that from perspective as well. And we will have a 3D version. There is already a beta version of GeoGebra on 3D. So you can already try the beta version of 3D. So then that should be a real 3D environment. And also what you can do is you can use 3D glasses for students to be able to see it in real 3D. So if you would like to try it, then you can already try it. It's not very stable yet, but we try to make some improvement of the 3D development. Okay. I hope it's not too fast. Okay. We also try to introduce programming languages like Python. So in that case, using a Python programming language can be introduced with the GeoGebra environment. So in that case, computer science subjects could be introduced. So then there is some video here which shows some of the Python languages. And what is a very new development is is a new field of mathematics since the 1970s, is automatic proving. So the four-color theorem was the first automatic or computer-generated proofs. But there are lots of development in this field, and we hope to have this automatic proving working in GeoGebra. So, and it's mostly done in Spain. Okay, and as I mentioned before, GeoGebra is used in mathematics, but now it started to be used in different fields. So science, technology, engineering, mathematics, that is STEM. So for example, there are some data loggers in different countries. This is, for example, an Indian data logger which costs about $20. And then you can measure electricity, light, sound, and so on. And then you can analyze the data from these sources in GeoGebra. And there are some projects which helps to drive robots with GeoGebra, and that is quite interesting. And also some experimental things, that real 3D environments or Kinect, so you can just use some data from Kinect to do this. We don't know what it will be used for, but it might be useful for the future, and it might be interesting for some other activities. And Raspberry Pi is a small computer which costs about $15, and then that is a similar version of the laptops in England. So they just give these small computers to students to learn computer science and some other subjects, and they use it in England in many schools, and they started to use in Brazil and in South Africa. So we try to run GeoGebra on these small computers as well. And the latest big step of GeoGebra is moving away from Java. So Java was the original language of GeoGebra, but in that case you would need to install GeoGebra as a software for your computer. But many software don't support Java. Many computers don't support Java. So we started to move to HTML5. So there is a version, a web version of GeoGebra, which is can be run in a browser. So any device which can run a browser could run GeoGebra. So now there is you can use it in any browser, but there is a Chrome application of GeoGebra on the Chrome web store in the Chrome browser, so you can download it. It's not the full version, but it's improving gradually as well. So it's a little bit different than the original version from the perspectives, but what we try to do is that moving the full Java version into HTML5, so you can download Chrome from the Chrome store. And GeoGebra on tablets. So 2 weeks ago we just released the new tablet applications for Windows 8, Android and iPad. And also this is a little bit different because touch devices have different needs, and you can try it if you have a tablet. It's not perfect, but we are on the way to develop it. So most of the resources are going to this direction, and then we really seek for feedback on this version of GeoGebra. So you can try the tablet version, and there are lots of other activities. So the One Laptop Per Child project, which is done in Uruguay and in other countries, so we have a version for this. You already know this project quite well. And of course there are a lot of GeoGebra textbooks. There are about 50 countries where there are textbooks of GeoGebra, and I know that there are some GeoGebra textbooks here as well. there are online assessment systems, so you would be able to use an assessment system to introduce GeoGebra and then test with this. And that TAO might be interesting, which is a project in Luxembourg, because the PISA testing will move to computers, and then probably TAO will be the environment. And if they introduce GeoGebra, then it could be dynamic testing in the PISA tests. And there are some online schools using GeoGebra. We have a YouTube channel, so there are lots of tutorials, and I know there are lots of videos here in Argentina for tutorials, so maybe it could be added to the YouTube channel. There is a Facebook on GeoGebra with some news, and Twitter, and we have a blog, and we have Agustin, who is our GeoGebra ambassador, and then he organized this event, or he invited me to be here at this meeting. So then this is about the perspectives of GeoGebra in the future. But what I would like to emphasize that so 10 years ago, most of the research was conducted in a way that schools and students and teachers would need resources. But because of this laptop project and some other activities and the more accessibility of technology, then accessibility is getting less and less important on the agenda in the integration of technology, because schools have much more technology, but we still in a very beginning way to understand that how technology really works in the classroom, and what does it mean to teach with technology, and what does it mean to have a mathematics as a subject with technology. So there was a time when most of the research which was being done with technology is that one classroom in a traditional way and the other classroom is with technology, and of course you can generate any kind of results. So students will learn better, same, worse. So, but then the problem is that we cannot really compare then the knowledge of mathematics and the kind of mathematics which is the outcome of this kind of environment, because then there is two different kind of environment. And of course, if we test the students on paper while they were using technology, they might even have some disadvantage. So what I would like to suggest that we really need to understand that what does it mean that technology influencing mathematics and technology is influencing mathematics education. So then that's why I try to coordinate some of these projects, which I call research, but it could be just a collection of good ideas and a collection of understanding of what is happening, and try to find out that what is an effective and successful way to introduce technology, and then being open-minded, and then that would really help us to see that which direction this integration is happening, because it will happen eventually. Then the question is whether we can work with this, and whether we would need this kind of integration, and what is the purpose of teaching mathematics in schools, because then there could be different ways to use technology. And GeoGebra could be one of the tools then that we might be investigating. And it could be also help us to improve the software. It helps us to give support for the teachers, and then it helps the teaching and the learning of the students, but we would need to invest some energy to this one. And there are already probably hundreds of projects, many masters and PhD theses, but what I feel is missing, that the coordination and the understanding. Maybe in one university do this kind of research and the other one some other things, and maybe both of them has excellent outcome, but they don't really know about each other. So what I suggest that we should try to communicate and collaborate with each other. And of course, if we want to make bigger steps, then probably we need to have some priorities on teacher development and beliefs on materials, that what is already there, because there are lots of things around, but there is no knowledge, and it's impossible to see that what is there, how to improve the software, what students learn, what is the difference between the new way of learning mathematics and so on. So what we try to do is try to coordinate this kind of research projects, and if you are interested, then we try to develop some of these activities here as well, or if there are already work being done here, then let's just connect with each other. So we try to encourage collaboration and sharing experience, and then try to support all of these experiences. And before we talk, that we want to what I do in Cambridge is I'm training masters and PhD students to be able to do research, and we try to establish a graduate school for masters and PhD students. And it might be a possibility that I talked with some people in Uruguay, that they would have some PhD students who would be trained for doing systematic research on mathematics education. And it might be a possibility here as well, that some of the PhD students who would do this kind of research could run some projects and an understanding of the activities with the laptops or something like this. And what I also wanted to mention, that one of these research activities, one of these main research activities is done in Europe. So we will start a European Union supported project in Hungary. This will be a very big project to see that how we can introduce technology into the Hungarian education system. So Hungary is have lots of nice traditions of teaching mathematics, and there are lots of Hungarian mathematicians, and the students are usually win the mathematical Olympiads. So what we try to do is try to collect all the good experiences with technology from all over the world, and also introduce it into the Hungarian system, and then see that how it would work. So then this could be a project which is exemplary in the EU. But what could be done is that we can learn from other perspectives and other cultures. So it could be done that in Uruguay, in Argentina, you could run similar kind of projects and see that how we can contribute to each other, because what we develop in Hungary, it could be shared with here, and then adapted for the curriculum and the culture, and then the same way, from a different perspective, we would learn lots of things in Hungary. So the project will consist of a new platform of a GeoGebra tube. So it will be improved to GeoGebra book, which consists GeoGebra materials, but also pedagogy and videos and all of the supporting materials for teachers and for students as well. So we plan to have some virtual classrooms and so on. And also we want to develop at least 1,800 high-quality teaching materials for mathematics and physics, and electronic textbooks from 1 to 12. So all of these materials will cover from primary to university level. And also we will involve about 800 schools and 2,400 teachers. So we will have a 60-hour training for all of these teachers. But what is interesting in the project, that a research project or evaluation will be run throughout the project. So each step of the project we try to evaluate that how it would work, and then see that how it could be developed and improved all of these materials. So I think if we do this kind of work here, then this is one of the most important one, that try it in small and then utilize it, the research result, and share the results together. So then that might be an interesting way to work together in the future. So to sum up, so if you are interested, then you can join any parts of the community, the research, or being a volunteer, or just do whatever you do in your everyday work. So you can find all of these materials on the web, and if you write your email address on that paper, I will send this presentation and the files to you if you would like to have. And thank you very much. So if you have any questions, then please let me know.
Y entonces dejamos un rato para quienes tengan alguna pregunta o alguna sugerencia o alguna duda, y aprovechemos que lo tenemos acá a George a mano. Yo le voy a preguntar una de las que hizo hoy más temprano, pero ustedes no estaban. Es que hoy en la presentación anterior, que éramos un grupo más chiquito, George habló, estuvimos hablando un poco filosóficamente también de la introducción del software para resolver problemas, y él dijo que había dos matemáticas. Dice, bueno, porque en verdad hay dos matemáticas. Y después siguió el desarrollo de la charla y me quedé sin saber cuáles eran esas dos matemáticas. No sé si ahora se va a acordar de eso que dijo en ese momento, pero hablando de la matemática escolar, creo que se refería a la matemática del matemático y la matemática del profesor o del maestro de matemáticas. A ver si por ese lado GeoGebra, ¿de qué lado de las dos matemáticas está?
Yeah, so what I meant on the different kinds of mathematics, that in relation to the introduction of technology, is that when mathematicians work, then they do it with a very creative way. And the introduction of technology into mathematics as a discipline, then you see that with technology there are many new fields of mathematics, like computer science and graph theory, and many of them, the subjects are very much influenced by the integration of technology, of statistics. Then that is really much improved because of technology. But what we have in the schools, the school kind of mathematics is more like the teacher telling the students that this is mathematics, and then it's finished. It's not really an exploratory way. But when we introduce technology into the classroom, what I usually see is that the old style of mathematics, what we were doing on papers, then exactly the same is replicated with the computer. So there is no really novel way. So there are some, but now really a novel way of introduction, and then that is the kind of mathematics what I meant in schools, that technology is being integrated, but not very much in a revolutionary way as it's being integrated into the subject. So for example, there were a study in England when they asked the teachers to integrate technology into the classroom, and there was a very little percentage of teachers used technology in the classroom. And when they looked at that, what is the integration of technology, as they prepared some PowerPoint slides, and then they just pushed through the PowerPoint slides. So even if probably 10% of the teachers use technology, probably only 0.5% or even less used it in a way which is beyond PowerPoint. So I think then that is the kind of way that the use of technology in education is delayed by the use of technology in the mathematics as a discipline. I think is it the question?
Sí. Bueno, y ahora les toca a ustedes.
Me quedo con los comentarios y te hacer una pregunta que va sobre esta forma en la que la tecnología puede estar en la clase. Recién cuando en tu primer archivo de GeoGebra mostrabas el triángulo, yo me preguntaba cuál era el problema que podría vivir en una clase para que ese triángulo tuviera algún sentido. Los problemas de geometría, como estamos acostumbrados a verlos en la escuela, son problemas que traen preguntas acerca de propiedades de esos objetos. Mi pregunta y mi observación respecto de la problemática de la entrada de GeoGebra o algunos otros software similares es en qué medida la entrada de la tecnología no tapa o responde todas las preguntas o tapa la posibilidad de hacerse preguntas, hacer conjeturas y producir algún tipo de construcción que traiga respuestas. No sé si está clara la pregunta, pero la idea es tratar de entender cómo el GeoGebra puede acompañar una construcción de preguntas y de respuestas en una clase, siendo tan potente como lo es.
Yes. So I think then that's what I wanted to show, that we should ask different kinds of questions, because then the question is that what we talked with Andrea, that a triangle. So if we draw a triangle on a paper, then it will be one triangle. If we draw a triangle in GeoGebra, that will be every triangle. So we cannot really ask the same question, because in that case, what you are saying, that if we do it in dynamic geometry, then it will give all the answers. But we don't want to ask the kind of questions which will give all the answers. So then that's why we need to come up with different ways of asking and different propositions of questions. So then that's why I'm suggesting investigation with this triangle experiment, is that asking students that construct something like the perpendicular bisector, and then what do you observe? And then we don't show them that what they observe. They come up with these kind of things. And then if the teacher can adopt this kind of role of being a conductor of the classroom, the students will already know mathematics, and then they already can discover. So in that case, what is my experience, what I explained before, that most of the mathematics which we require students from schools, they already know it. They just need to be allowed to discover, and then what we can do is showing them a range of tools and allowing them to explore with a well-constructed question. So we need to pose problems and then give them a range of tools and then let them work together to solve the problem. And what we talked in the previous session, what we really need to do is try to train inspiring teachers, because if we can get inspiring teachers, then the students will learn whatever it is. An inspiring teacher could be someone who uses technology in different levels, but what is needed is to suit for their own style and teaching. I don't know if it answers your question.
Bueno, buenas tardes. Muy interesante todo hasta ahora. Yo lo que quería preguntar es lo siguiente. Nosotros, en general, bueno, yo soy bastante viejo acá, pero cuando aprendimos matemática, la aprendimos de una manera distinta a lo que lo estamos enseñando ahora. Entonces, yo lo que veo que cuando estoy dando mis primeros pasos en aplicar la tecnología, veo que cada cosa que hago me sorprende terriblemente, me deja, digo, pero qué bárbaro esto, pero mirá cómo puedo obtener el área de una curva bajo una curva en forma, verla ahí, ver en la superficie, y lo que veo es que los alumnos no se sorprenden para nada, porque ellos tienen otro chip, tienen otra cosa en la cabeza. Entonces, ¿cómo hacer para que ellos se sorprendan como nos sorprendemos nosotros? Parece que estamos aprendiendo más nosotros que ellos. Entonces la pregunta es esa: ¿cómo hacer para que el alumno se sorprenda con estas cosas de la misma manera que nos sorprendemos nosotros?
I think this is how you can do it. So if you are surprised and then you can convey this kind of surprise to students, then this is the only way we can surprise students. So if you find something which is amazing for you, and then if you are motivated from the inside, then that is how you can motivate the students. So I think that is the only way. Of course, there are some problems with the entire setup of schools, and also some of the attitude of the students. But I think if you remember, then probably the inspiring teachers you learn the most, and then that is the only way to inspire students if you are inspired.
Entonces vamos a despedir al profesor con otro fuerte aplauso.